Hi everyone, welcome back to my channel. Let's continue from where we left off in the previous session. Today we will be moving ahead with the next part of the topic, so let's get started.
Now let's do the question number 4 of exercise 6.3. It is given that in the figure QR by QS equal to QT by PR and angle 1 equal to angle 2. What we have to show? Show that triangle PQS is similar to triangle TQR. Therefore, first we have to write what all things are given in the question that we have to write. Copy it down there. QR by QS equal to QT by PR. Again, angle 1 is given equal to angle 2. And what we had to prove? We had to show that triangle PQS is similar to triangle TQR that we had written here. Now, we need to do the proof. Okay, they have given angle 1 equal to angle 2. Okay, so let me draw a triangle which contain both these triangles, both these angles, angle 1 and angle 2. Okay, here if I'm looking here one angle 1 is there, angle 2 is there. Which is the triangle which contain both angle 1 and angle 2? Here Q, here it comes the R, the line joining the blue colored line that ends there in P. Therefore, the obtained triangle is PQR. Okay, so if you're looking, the base angles are equal. That means PQ equal to PRY. If this is an isosceles triangle, angle 1 equal to angle 2. Therefore, its sides will be equal. Which side? PQ and PR will be equal. Therefore, we will give this equation as equation number 1. Okay, now what is our aim? We have to prove that triangle PQS is similar to triangle TQR. So let me draw these two triangles. Triangle PQ yes, and triangle TQR. Now I have to draw these two triangles. Okay, triangle PQ yes and triangle TQR. These are the things which I have to prove. Okay, now again one more thing is given in the question. What is given? QR by QS equal to, it is equal to what? QT divided by PR, right? So, if you are checking here, QR belongs to this triangle, QS belongs to this triangle, right? And now here comes the QT. QT belongs to this triangle, and but now denominator it is the PR. Now we have to check whether this PR have any connection with this triangle. Now look at the equation number 1. From equation 1, what is our equation telling? Equation 1, it says that PQ equal to PR, right? PQ equal to PR. So what we can do, let this be the equation number 2 and this is equation number 1, no? Substitute, what you can do? Substitute equation 1 in equation 2. Clear? What is our equation? QR by QS equal to QT by PR. But what will I do? I will replace this PR using PQ. Okay, that means I got QT by PQ, right? So now I can tell that the sides are proportional, right? Two sides are proportional, and if I'm looking here in both the triangle, Q is coming as a common angle, right? Look, this Q is coming as a common angle. Therefore, I can write angle Q equal to angle Q. So, yesterday we have learned if two sides are proportional and the corresponding angle is equal, then we can tell that those two triangles will be similar. Using which criteria? By using SAS criteria. So, now look here, we got what? We got angle, therefore, triangle PQS, it is similar to triangle TQR by using which criteria? By using SAS similarity criterion. Okay, hence proved. Now let's do the question number 8. In this question it says that E is produced on the side AD of a parallelogram ABCD. So first let me draw a parallelogram called ABCD. Here I am drawing it in this way. ABCD is a parallelogram. So let it be A, B, C, D. AD produce, so E is a point on the side AD. So I will have to extend the line. Which line? This AD in a straight way. Okay, there I will get a point called E here. Okay, produce on AB and BE intersect. And BE intersects means what? If I'm connecting this E and B, what will happen? They will intersect each other. Okay, let that intersecting line be this one. And they intersect at the point called what? Intersect at F. That means this point is F. Show that triangle ABE is similar to triangle CFB. We have to show which triangle ABE, that is this triangle, right? This ABE is similar to what? AB is similar to CFB. That is which triangle? Let this triangle be this one. CFB means this one, right? They are asking us to show that these two triangles are what? Similar. Clear? So now let me take the triangles. Which all triangles? Triangles ABE, in a triangle ABE and triangle CFB. What all things I can write? Since ABCD is a parallelogram, I can write some things, some more things here, right? What all things I can write? ABCD is a parallelogram. Therefore, AB is parallel to CD. AB is parallel to CD and AD is parallel to BC, right? And so from here, look here, this angle will be equal to this angle. Why? Parallelogram, in a parallelogram, opposite angles will be equal. If ABCD is a parallelogram means what? Then angle A equal to C, angle B equal to angle D. Therefore, here I can write, therefore, angle A equal to angle C. Why? Opposite angles of a parallelogram. I have to write here the reason. Opposite angles of a parallelogram. That is the reason for that one. Next, I can write one more thing. Look, this line is parallel to this line. That is, AD is parallel to BC. Let me draw that one here. I am just changing the positions. This is A and AD and this is BC. And if you are looking here, you can see that, let it be A, B, this is C, this is D. And you can see what? You can see BE is a transversal line, right? Okay, this is a line produced after from here. Clear? So, one more thing we can write. This angle will be equal to which angle? No, this angle, not that angle. Here we are getting this angle, right? If you are observing here, we can see that this angle will be equal to which angle? This angle. Why? Because these are the two parallel lines and we can consider this BE as a transversal. Right? If BE is a transversal and AD is parallel to BC, means AE is also parallel to BC, because AE is formed when AD is, we are extending the line AD. Therefore, by angle AEB is equal to angle CBF, right? Why? They are alternate interior angles. Clear? Then I can write here, right? Because they are alternate interior angles. Alternate interior angles as AE is parallel to BC. Now look, I got two two things. One is first one is this one, and second condition is this. So since it satisfies two condition, I can tell that these two triangles are similar. No, yesterday we told that if two angles we are able to prove like this, we can tell that they are similar by using AA criteria. Therefore, triangle ABE is similar to triangle CFB by which criteria? By AA similarity criterion. Clear? If you have any doubt, you can, this belongs to what? Angle A. This is an angle. Again, this is another angle. So what we can prove by using AA criteria, right? Hence proved. Okay, now let's do the question number 10. CD and GH are respectively the bisectors of angle ACB and EGH such that D and H lies on the sides AB and FE of triangle ABC and triangle EFG respectively. If triangle ABC and triangle FEG are similar, then what all things we have to show? We have to prove that CD by GH equal to AC by FG. Then triangle DCB is similar to triangle HGE, and triangle DCA is similar to triangle HGF. So in order to show this one, let us take these triangles. So one more thing, it is given, right? D and H lies on the side AB and FE in such a way that the CD and GH are respectively the bisectors. Look at this, bisectors of angle ACB and angle EGF. Bisector means what? To divide it into two equal parts. They are telling here, they are mentioning about the angle. So it means what? The bisector DC means what? DC bisect angle ACB into two equal parts. That means what? Angle 1 equal to 2. Clear? Since GH is the angle bisector of triangle FGE, it bisects the angle G. Therefore, what will happen? Angle 3 equal to angle 4. Why? Why angle 1 equal to angle 2? Because CD is the angle bisector. CD is the angle bisector of angle C, right? And GH is the angle bisector of what? GH is the angle bisector of angle G. Clear? Therefore, we will get angle 1 equal to angle 2, angle 3 equal to angle 4. Also given, look here, triangle ABC is similar to triangle FEG. Given triangle ABC is similar to triangle FEG. We have already learned that if two triangles are similar, it means that angles are equal. Okay, and sides will be proportional. Here, they didn't mention about any proportionality, nothing like that. So, we can directly take both angles, corresponding angles are equal here. So, we can take angle A equal to what? Therefore, angle A equal to angle F, angle B equal to angle E, and next one is angle, which is the next angle? Angle ACB equal to angle FGE. Clear? Why here I wrote like this? It is because here you can see that there is an angle bisector going through that part. So that's why I expanded the angle's name as angle ACB as well as angle FGE. Clear? Now we can write what? In triangle, next one we have to take. Which all triangles we have to take here? This comes in triangle ACB and in triangle FGE. Here we have to prove that CD by GH equal to AC by FG, right? So let me take the triangle A, C, B and in triangle FGE, these all things are happening, right? Now look, CD by GH. CD is which part? CD is this one, right? And GH is this one. Now look, AC is, which is the AC here? AC is this part. And FG is what? This part. So I have to take which triangles here? I have to consider the triangle, these two triangles. Which triangle? Triangle. Therefore, in order to prove this one, what I will do? I will take these two triangles. In triangle ADC and triangle FGH. What all things I can prove here? I can tell that angle A equal to angle F, right? Next, one more thing. Here, if you are looking here, I can write what? If angle 1 equal to 2 and angle 3 equal to 4, also here you can see that this is, let me give this one as equation number 1. And here you can see again this one as equation number 3, right? That is angle C. Total angle C is equal to total angle G. And if angle 1 equal to 2 and angle 3 equal to 4, automatically what will happen? Angle 1 equal to, angle 2 equal to, angle 3 equal to angle 4, right? So I can write what from here, comparing all that actually on comparing, or otherwise from equation, which all equation? From equation 1, and this one let me give it like the equation number 2 and 2. What I can write? Angle 1 equal to angle 2 equal to angle 3, which is also equal to angle 4, right? Therefore, I can write here one more thing, right? That is what? Angle ACD equal to angle FGH. Clear? In that way, we can write that part. So now I got here one here. This is the fourth one. From the 3 and 4, what can I write? Therefore, triangle ADC is similar to triangle FGH. If these two triangles are similar, then by using which criteria I can write that one? By using the criteria, here we use the angle, right? Then again here also we use the angle, right? Here also we used angle, right? So angle. So which one? So by using which criteria? By using AA similarity criteria. By AA similarity criterion, we can prove that these two triangles, triangle ADC and triangle FGH, is similar, right? Now, if these two triangles are similar, automatically what we can write? We can write that the corresponding sides are what? The corresponding sides means included angles. Now look, this angle and this angle, right? So what I can write it here, therefore its corresponding sides are also proportional. Because of this reason, I can write CD by GH is equal to AC by FG. Because I got what? I got my triangle ADC similar to triangle FGH. So I can write these are equal. Its sides are proportional. Now let's do the question number second part out of it. Okay. Same question, second part. In the second part, we have to show that triangle DCB is similar to triangle what? Triangle HGE. In this part, let me draw this triangle separately. Which triangle? Triangle DCB and triangle HGE. How to draw that one? That is triangle. This is triangle. Let it be the DCB and let this be the triangle HGE. Okay. Let me write D, C, B and H, G, E. Clear? Here, this is angle 1 and this is angle 3, right? So here, how can we prove that these two triangles are similar? No, it's very easy because already we have proved what angle 1 equal to, angle 2 equal to, angle 3 equal to, angle 4. This we have already proved, right? What we can write? Proved above. So from here, what we can write? Angle 1 equal to angle 3. That is which angle? Angle DCB equal to angle HGE. So we can write here what? Proved above. Okay. Now next one is again angle B equal to what? Angle B equal to angle E. Why? Because the triangles are similar, right? Already they have given us triangle ABC similar to triangle FEG. Therefore, that is also because triangle ABC is similar to triangle FGE. Therefore, we can write that angle B is equal to angle E. Hence, we can write what? Therefore, triangle DCB is similar to triangle HGE. Hence, proved. Now, let's prove the third one. That is triangle DCA similar to triangle HGF. This one we have to prove now. So, first let me draw that triangle here. Okay, this is D, A, C and this is H, F, G. This is angle 2 and this is angle 4. Okay, so how to prove this one? Like we have already proved that angle 1 equal to angle 2 equal to angle 3 equal to 4. Therefore, in triangle ADC and triangle FHG, angle 2 equal to angle 4. That is proved above. Okay. In the starting of the question itself, we have proved that one. Now next, what we can write? This angle equal to this angle. Why? Because triangle ABC is similar to triangle FEG. Therefore, an angle A equal to what? Angle A equal to angle F. Why? Because triangle ABC similar to triangle what? Triangle FEG, right? So we can tell that these two triangles are. Now we got two angles. Therefore, I can write what? Therefore, triangle ADC similar to triangle FHG. Correct? By which criteria? By AA similarity criterion. Right? Hence, proved. Okay, now let's do the question number 11. In the figure, E is a point on the side CB produced of an isosceles triangle ABC. That means what? If triangle ABC is an isosceles triangle, also given what? AB equal to AC. Therefore, automatically what will become? Angle B is equal to angle C. Also given here what? AD is perpendicular to BC and EF is perpendicular to AC. What we have to prove? We have to prove that. To prove what? To prove triangle ABD is similar to triangle ECF. So how to do that one? Let me first draw these two triangles separately. Which triangles? Triangles ABD and triangle ECF. ABD and ECF. And if you have any doubt in drawing this figure, you can do one thing here, which is triangle ABD here. ABD, this triangle, right? So this one is the one which we are copying to this side. Look, A, this is B and this is D. This is a perpendicular line. Okay, now we have to take which one? Triangle ECF. Look, ECF means E C and F. This part, right? So similarly, which is that part? This is E. Then comes the F, that the perpendicular one, and this comes the C, right? Now, what all thing we have to prove these two triangles are similar. So for that one, in triangle ABD and triangle ECF, what all things I can write it here? Angle, we have already written what angle B equal to angle C from where, since it is an isosceles triangle. Therefore, I can write it here, angle B equal to angle C, right? Why? Angles of an isosceles triangle. Then here instead we can write proved above. Next one is angle ADB equal to angle EFC, right? Which is equal to 90 degree. Angle ADB equal to angle EFC because each 90 degree, right? Okay. Now, therefore, I can write what? Therefore, triangle ABD is similar to triangle ECF. By which criteria? By AA similarity criterion. Okay. Hence, we have proved this also. Okay. Hence, we can write hence proved. Clear? So, in the question number 12, it is given sides AB and BC and median AD of a triangle ABC are respectively proportional to the PQ, QR and median PM of triangle PQR. That means this AB is proportional to what? AB is proportional to the side PQ and BC is proportional to the side what? QR, and the median AD of triangle ABC. So this median AD of triangle ABC, it is proportional to the median PM of triangle PQR. That means AB proportional to what? PQ. Okay. Next one is BC. That means the lower one. This one. BC is proportional to QR. Next one is what? Median AD. This is proportional to median PM. Right? It means, what do you mean by a median? Median means a line segment drawn from a vertex to the midpoint of other side. Okay, means midpoint of the opposite side. Here the line segment is starting from A and it is joining at the midpoint of BC, that is D. D is the midpoint of BC. Similarly, M is the midpoint of QR. The line joining this P and its midpoint M is called the median, and in the triangle ABC, the line joining the vertex A and the midpoint D, that is a midpoint of BC, that line segment we will call it as the median AD. Okay, so what they are asking us to prove, we have to prove that triangle ABC is similar to triangle PQR. What all things are given in the question? Here it is given these three things, right? So how can I write here? AB is proportional to what? AB by PQ equal to, I can write BC by QR, which is equal to AD by PM. It is given in the question. Okay. Now look, this what does the median does? Median divides the opposite sides, right? Opposite sides. That means D divides what? BD equal to half of BC, right? Similarly, QM equal to half of QR. When we will divide the QR into two parts, we will get QM and MR. When we will divide BC into two equal parts, we will get BD and DC, right? So, now, this is equation number 1. Okay. Then, we have to take, first let me write it here, AB by PQ equal to BC by QR, which is equal to AD by PM, right? AD by PM. In this case, what I will do, AB by PQ equal to next one, which is BC by QR. Instead of BC, I can write, I'm going to take the half of BC on both side. I'm going to take its half. I'm going to multiply with half on both sides of the second equation. That is half of BC divided by half of QR. Then I will write again, I am continuing our equation, AD by PM. What is half of BC? Here we have written, right? Half of BC is BD and half of QR is QM. Right? So I can rewrite that one. Let it be the equation number 2 and let this be the equation number 3. And let it be the equation number 4. Okay. Substitute 2 and 3 in equation 4. Clear? That is, what will happen? AB by PQ equal to, instead of half of BC, I will replace it by BD. And instead of half of QR, I will replace it by QM. QM equal to AD divided by PM. Clear? Now, what I can write here? AB by PQ. Look, which is that line? AB by PQ. AB by PQ equal to BD by QM. BD by QM is this one, BD by QM, which is equal to AD by AM. That is this one. So, hence I got what? These two triangles are similar triangles, right? Which two triangles? Triangle ABD and triangle PQM. Clear? So, I can write here, therefore, triangle ABD is similar to triangle PQM. Right? If you want, you can check once again. ABD is similar to triangle PQM. Right? So, by using which criteria? Since all the sides are proportional, we can write it by using by SSS similarity criterion. Okay, now we got triangle ABD is similar to triangle PQM. If triangle ABD is similar to triangle PQM, what all things we can write? We can write angle ABD equal to angle PQM. Then again we can write angle BDA equal to angle QMP. Again angle DAB equal to angle MPQ. These are the things which can write using this similarity criterion, right? So, now let's, what is our question? Question is that we have to show that triangle ABC is similar to triangle PQR. Therefore, let us take the triangle ABC and PQR. In triangle, which triangle? ABC and triangle PQR. What all? Let me redraw the triangles again here. That is like this. Let it be like this. This is A, B, C, P, Q, R. What all things I can write here? AB by PQ equal to what? BC by QR. Right? Look, that is from where? AB by PQ and BC by QR. That is the first one, right? Equation. From here we can write that one. From 1. That is from equation 1, right? Then we can write what? Now look here. Here we have proved that. One more thing. What is that? Angle ABD. Instead of angle ABD, we can write it where D means still here, right? And this is PQM means still here. But we can extend the arm and we can write it like angle ABC equal to angle PQR. Correct? That is from where? From this one. From here we can write that, let it be the equation number 5. From equation 5, right? We can write angle ABC equal to angle PQR. Therefore, now from these two things we can write, therefore what? Therefore, triangle ABC is similar to triangle PQR. By using which criteria? By using SAS criteria. By SAS similarity criterion. Okay, we can prove that these two triangles are similar. Hence, it is proved, right? Hence, proved. Clear? Let's do the question 15. A vertical pole of length 6 meter cast a shadow 4 meter long on the ground, and at the same time a tower cast a shadow 28 meter long. Find the height of the tower. So here they are telling that let AB is the pole. Okay, its length is how much? Length is 6 meter, and it cast a shadow. This BC is the shadow, and its length is how much? It is 4 meter long. Okay, then it is on the ground, and at the same time a tower cast. Let DF, they are giving DF as the tower. Okay, and what is the height of the tower? We don't know. Let us give the term H there, and it cast a shadow of length how many meter? 28 meter length shadow we will get there. Okay, we have to find what is the tower height. We have to find the height of the tower. So if we want to find the height of the tower, how we have to do? We have to first prove that these two triangles are similar. If these two triangles are similar, then we can write the sides are proportional, right? Then using the proportionality, we can find it. Okay. So first we have to find what? We have to find whether these two triangles are similar or not. So in triangle ABC and triangle DEF, what all things are given in the question? It is already given that this angle C equal to angle E. Okay, angle C equal to angle E. Then they have given this is perpendicular height, right? So angle B equal to angle F, which is equal to 90 degree. Okay, therefore what we can tell? Now we have proved two angles, right? A. Therefore we can write, therefore triangle ABC, it is similar to the triangle DEF using which criteria? By AA similarity criterion. Okay, we can prove that these two triangles are similar. Now what we can write? Therefore, triangle ABC, it is similar to triangle DEF. Okay, we have proved here, right? So, if these two triangles are similar, what I told, then we can use which theorem? That is using the proportionality. If these two triangles are similar, then automatically what we can write? AB by DF equal to, what will happen here? BC by EF, right? AB by DF equal to BC by EF. Then, what is the value of AB here? The given value for AB is 6 and given value for DF is how much? DF, I don't know the height of the DF. There we gave the height H, which is equal to BC. What is BC here? 4 divided by, and EF is 28. Now we can find the value for H. 6 by H equal to 4 by 28. So how to find H? I need to take the H to this side. So H equal to how much? H will go there and these two terms will come in the opposite side. That is H equal to 6 into 28 by 4. Right? So what I will get here? This one and this one I can cancel and I can write 7 4s are 28. And what is 6 7s are? 6 7s are 42 meter. So I got the height. H is equal to how much? 42 meter. Hence, I can write what? Hence, height of height of the tower is how much? Is 42 meter. Okay. Thank you for watching. If you found this helpful, please subscribe and stay connected.